plenty of seats left. Good. So, hello, and nice to see all of you here. My name is Fabian Deutsch, and I'm working for Red Hat. And my background is basically I am a Fedora user for the last, 17 years, 18 years, with adventures to Gentoo and all the other distributions, SUSE, Ubuntu, and so on and so forth. And finally I landed at that place where you get a Red Hat when onboarding. And the last 4 years I spent working really on virtualization at Red Hat on Rev, which is the downstream product of the upstream Overt project, which is taking care of having a virtualization management system for VMs in the classical sense. And today, I want to talk with you. Please ask questions if you have them, or we defer them to the end. But today, I would really like to speak with you about pet VMs in Kubernetes, and what the heck, how can that work? Because, the question is, why? Why do you combine these words anyway, VMs and Kubernetes? So how many of you do know Kubernetes? A few. How many of you do know containers? About the same number. And how many of you are using virtual machines? That's good. So that's an ideal. Then you're on the right talk. So here it is about to see how can you take your pet VMs you have today and run them in Kubernetes, or if it's possible at all, if it's feasible, if it makes sense, or if it doesn't make sense from our perspective. So to get into the topic, just to let us define the terms pet VMs and Kubernetes or containers before. So if I speak about pet VMs, then I really mean VMs which you care about. I mean, you take your MySQL database and tune it for 15 days so that it has all the specific properties you want. Or you create a virtual machine which is for your workmate, providing a desktop, and you set up multiple monitors, you set up USB forwarding for, your USB camera so he's able to do Skype. So a pet VM is really something handcrafted. You spend time on modifying it, on making it specifically work for you. And you notice that you have got a pet VM, so when you delete it, you say, oh my God, I deleted my pet VM, and it's really an issue that I deleted it. And then somebody is probably telling you I guess you have a backup, and you can restore it. On the other side, we've got Kubernetes. I don't want to directly compare Kubernetes and pet VMs, because one is a management system, the other is an instance, basically. But I took Kubernetes because in Kubernetes, they care about containers. And containers are to some degree similar to VMs, as they run a workload. So they run something for you, but the assumptions about the container are different. So a container is an instance of an image which is pre-built, and you can create 1,000 gazillion instances of that image, and all of them are the same with some minor differences, like different MAC addresses and so on and so forth. And you know that you've got a container if you notice that, I deleted my container, and you don't even notice it. So it really it's normal that containers go away. It is expected that they go away and reappear on a different host, but they serve a specific purpose. That is what they're built for. So that is for these two terms. Now, and Kubernetes, and containers and VMs are both run and managed by management systems. So on the one hand side, you've got a container cluster, which, for example, you can use Kubernetes to manage a cluster where you can run containers on. With all these assumptions, Kubernetes is specifically built to run containers in the way they were created for. So we've got, for example, replication controllers. All of you who lifted the hand know it. Replication controllers are there to keep a specific number of containers or pods in the Kubernetes sense up and running on all the hosts available in the cluster. If a host goes down, Kubernetes does not care so much, but just ensures that the missing containers are brought up into a different place again. On the other hand, we've got a different cluster system for VMs, like Overt, where you also got a set of hosts which you manage with a central interface, and you can instantiate your pet VM, and then you start tuning it, maybe use Ansible, and maybe it's even pinned on a specific host because you need specific hardware. So, and the assumption on where this management system is built around is about taking care that you can really manage the VM with all its details. So multiple displays, device path-through, USB path-through, optimized protocols to view the content of the screen like SPICE. So all of this is built into the management system. But both of them are management systems to some degree for their specific workload. So for both management systems, in their sense they differ, but if you take a step back, both of them are management systems which is tuned towards a specific workload. So they're workload-specific management systems. So these management systems differ in their workload specifically and the functionality tuned towards it. But they also have stuff in common, the infrastructure. So if you look at containers, they also need storage to store your data. They also need network to get access to your network, to expose their functionality. And you've got the same stuff on the VM side. You also need storage to store your computed results. You also need network to expose your VM to get access to it. So despite the differences, there are also some things in common. Oh, scheduling, for example, is also something which you don't see at a first glance, but both management systems need to take care to find the right spot on any given host in the cluster and decide, do I put my workload on that host or on a different host? Host lifecycle management is also something you normally or you often don't see, but you also want to have a way to say, for example, I want to update my host, so I need to make sure that all VMs running on that host are moved away so that I can safely update the host and apply a new kernel update. So that being said, if we had a management system where we do have the same, the goal now of KubeVirt is to have a management system where the infrastructure layer is shared between both workloads so that you can run VMs and containers on the same infrastructure because the infrastructure is so much the same. The question is how we can get there, and that is what is KubeVirt about. I mean, there have been a few approaches how to get VMs into Kubernetes, and they were in a specific way, which we'll get to in a moment, and that was mainly the reason of why we want to do it, because we want to reuse the infrastructure, and the side benefit is then that you are able to run both workloads on the same infrastructure, which is pretty efficient. And allows you, by the way, the same migration from the one system to the other or the other way around. Okay, so what we did is we did a first try to achieve this. So we tried we approached this problem because we said we want to use the infrastructure of Kubernetes. So how can we run VMs on it? And we put our hands on it. The first try we did was we tried to replace Docker. Back then, it's about, a year back. We looked at Kubernetes and looked, okay, how can we do it? We went to the Kubernetes source code and looked, okay, let's replace the Docker calls with a QEMU command. Yeah, I mean, from the high level, in detail, it looked a bit different. So we did it, and you can spawn a VM by Kubernetes. The host daemon can be modified to launch QEMU instead of Docker and bring up a VM instead of a container or a pod, which are multiple containers. But in the end it failed. It didn't look right. So why? Because we noticed, we got Kubernetes to launch a VM. And by the way, today that's much easier to do because there's the container runtime interface and there are several implementations like runv and the Virtlet, which do what we did in the source code with a defined interface. But it's so, for our use case, where we say we care so much about VMs, it looked ugly because we now had running VMs, but they were defined by the pod specification. So the pod specification is basically describing how does the container or the number of containers look which are running on top of Kubernetes. And this specification was not expressive enough to describe the pet VMs we wanted to run. We had no way to specify the number of monitors to use or which PCI device to use or it's quite common to public network and maybe a storage network and some other networks alike. And it's not possible to express that in the pod specification. Right, and the handling was an ugly implementation because we wanted to support both workloads, containers, and VMs. We had to add many conditionals to make sure that containers were running and VMs. So especially the representation was an issue because the pod is, after all, not as expressive as a pet VM. So we took some time, thought about it, and did another try. And that's KubeVirt. So KubeVirt is another effort, or this time we take it serious and we learned with all the stuff we did wrong in the past, and we position KubeVirt as an add-on to Kubernetes. So there are already a couple of add-ons to Kubernetes, like SkyDNS, for example, which you can deploy on Kubernetes as native Kubernetes applications, because they are self-contained and you can just use Kubernetes entities like deployments to deploy them on Kubernetes itself. And KubeVirt is not about modifying Kubernetes itself. So, for example, in the technical detail, then to get the kubelet to run VMs, but rather to find, it's threefold. So it's rather to find the right resources in Kubernetes. So if you know Kubernetes, you know there are pods and there are replication controllers, there are deployments. And KubeVirt is about finding the entities to represent VMs and all the ecosystem we've got around it. So VMs, networks, disks, and identify how we relate all of these entities to each other. All of this is not done directly inside of Kubernetes, but as an add-on, using third-party resources if you're interested. But that's just the representation side. To make Kubernetes being able to handle these new entities in Kubernetes, we then also had to come up with new controllers and daemons, which handled it on the cluster side and on the daemon side. I'll get to that in a moment. So in general, it then looks like that. So is there a pointer here? Oh, cool. So you've got Kubernetes, and there we wrote additional controllers which just handle VMs. So whenever you create a VM entity, this control, oops, that's the wrong thing. Ooh. Yeah, there you go. You press the wrong button, and all is gone. Oh, yeah. Don't press the red button, Mr. President. So, of Germany. So we wrote additional controllers which handle the specific specific logic, because in Kubernetes there are already controllers and they are tuned towards handling pods. So there's a controller which is handling garbage collection. There's a controller handling replication control, and they are not intended to handle VMs. So they are intended for pods. So we added our controller, which is using the same approach as all the other controllers. It's reactive to the VMs created in Kubernetes. It's following a declarative approach. So it feels like it is Kubernetes, but it's an add-on. It's added separately because we believe we need to focus all the Virt-specific stuff outside of Kubernetes. That is why we deliver it as an add-on. Then we have the Virt handler, which is running on the kube or alongside the kubelet on the host, which is then actually responsible for bringing up the VMs. So taking this picture here, you got your controller, which is scheduling a VM onto a specific host. The Virt handler is seeing, oh, that logical VM is scheduled on my host, so I make sure to really bring up a VM and specify it with all the details which a pet VM has. That's actually not just in theory, but, that is the broader concept. So it might look simplistic for now, and it's pretty abstract, but it's not just abstract. So we actually wrote the code, and you can even try it. So I would encourage you to just give it a try and look at the architecture yourself if you're a developer, or try it and play with it if you're interested in seeing how you can interact with it. We've got a small demo prepared, which you can look up in the slides afterwards. So far, what I described, so you can define a VM, and we took care of VM entities, or KubeVirt currently, we are working with present on GitHub, is in the state that we have VM definitions, a very minimalistic VM definition. We don't have disks yet, and we don't have networks yet, for example, which are also essential for VMs to somehow make something useful with them. We don't have that yet, but we're working on it. What you can do today is, however, you can still deploy KubeVirt natively on your Kubernetes cluster and get a VM running. It's PXE booting and will not find anything, but you can still get a feeling of how you handle it. How you can create the VM entity in Kubernetes and how you can delete it, and that you see the VM is going away on the host again. So there is something to try, and there are some gaps, and we are encouraging you to contribute in case that you're interested in the same area. But as I said, disks, networks, and scheduling, for example, we have it in a primitive way, or in the Kubernetes way, is something which we want to add in the near future to make it more usable. So to give you a nice demonstration of how it looks to boot your pet VM on Kubernetes using the native formats you all know from the whole libvirt world and boxes and the management systems. So that's really the near-term future, but that's not where we stop, because we also need to take care of other virtualization-specific features. So we said we take Kubernetes as it is. And that means advanced features which we have for virtualization, like migration or block live migration, needs to live somewhere else. And that is exactly the stuff we then need to implement in our controllers and daemons, so that they are capable of knowing that it's running on Kubernetes and find a way how to deliver, for example, live migration. We know that live migration, you need to have a shared, if you don't do block live migration, if you have live migration, then you need to have a shared volume which is accessible on both the source and the destination. And these are difficulties currently with Kubernetes. So to enable ourselves to deliver this live migration to Kubernetes, we're not looking at bringing live migration to Kubernetes, but rather to see that we get Kubernetes to close the gaps we need or we have to deliver live migration on top of Kubernetes. Other stuff we want to provide is like templating, that you have VM templates. We want to provide, there are a lot of details, so I could go on that for that. A host API, so that you can do, host PCI path through. We live in a container now on a host, so we need to respect that the host might be used by other parties as well. So we need to find different solutions than we have today. Besides of that, and that's actually another benefit of this approach, is we also need to work with the Kubernetes community to improve the areas where we leverage Kubernetes extensions to provide our functionality. So TPRs, for example. We are using TPRs, so third-party extension resources, extensively, but Kubernetes has difficulties in these areas. So we hope to be able to work with Kubernetes to fix the gaps we have, like doing custom renderings on the client side. But these improvements are just not only for us, but also for other parties which use TPRs. For example, OpenShift is also using TPRs for cron jobs, for example, if I'm not mistaken. Please correct me if I'm wrong. So that is where we have, where Kubert is right, I think, because we fix the stuff in Kubernetes, which is beneficial to other workloads or other parties as well. So other parties benefit from these fixes, and we just provide as an add-on our functionality outside of Kubernetes. Snapshots and volume improvements are also something we need to do. As you know, VMs are working with raw devices or block devices, and containers work with file systems. That's obviously a gap, so we need to do some work there. We're actually already in discussion with how that can be solved. These are all gaps, we see them, and that's okay. And besides that, there are also things which are not so much a technical problem, but rather a conceptual problem, like live migration. I mentioned there are some requirements we have from the virt side, that you have shared volume, but in Kubernetes, there's currently no concept of being able to transfer a state, which a live migration is, to transfer a state from one side to the other, because it just kills the pod and it's gone, and you don't have the time to really migrate the memory and all the necessary metadata over to the other side. So we want to work with Kubernetes to say, hey, please give us the time to complete this transition or this migration before killing that pod. There are already some smaller knobs. They might not be sufficient, so we need to find solutions there. So it's not all easy, but there are also gaps. Besides that, I think all in all, at the bottom line, there are a lot of opportunities. So I think especially if we manage to beef up the infrastructure of Kubernetes to meet our requirements and the requirements of containers, because they will benefit from it as well, then it's a win for both sides. For us, because we have one common layer with Kubernetes providing the infrastructure, and us on top providing the virtualization functionality, which looks to the outsider a native Kubernetes property. Yeah. So, are there any questions? If not, then I would really like to invite you tomorrow to join our dev room in C236, where we will be hanging around, drinking water and cold drinks. And speak about KubeVirt, how some of these problems I mentioned can be solved. And maybe you've got some thought as well, what is missing or what we could be doing. So, questions? If not, ping me on IRC or anywhere else. Yeah.
I'm just kind of curious if you could talk for about 1 minute or so on what is in the virt handler and the virt manager components that you've added and what's kind of unique functionalities there.
Sure. So the question was if I could explain what the virt handler does. So the virt handler, I'm going back to the slide just so you have it in front of you. There we are. The virt handler is down here. So the virt handler is doing all the host-side logic to which is necessary to launch the VM. I mean, after all, the VM is running on a host. And the host needs, the VM needs to be connected to the local storage. So the virt handler is responsible for finding the right path of the block device and attach it to the VM. The virt handler is responsible for making sure that the right NIC, which you logically define in Kubernetes, by the way. So we assume that Kubernetes will get multiple network support at some point, and we are actively working on that. So if you have these logical networks, that the right network, the right physical virtual NIC is getting attached to the virtual NIC, that the right interface of the kernel is getting attached to the right virtual NIC of the VM. So doing all that host stuff. NUMA, for example, is also something which is important there. And, for example, providing the entry point for live migration, where you need a direct access from host to host. Yes, please.
That you mentioned that it's working with libvirt.
Oh, yes. We should highlight. So currently, because we don't want to reinvent the wheel again and spend 90% of our time on bringing up an abstraction layer for different virtualization systems on the host, we decided to go with libvirt. So currently in our demo, libvirt is running alongside the virt handler on the host to really do the hard lifting of the VM. What the virt handler is, it is doing the mapping from the logical concepts we have in Kubernetes onto the libvirt layer. So, libvirt.
Yeah. Libvirt runs inside the container, though, or on the host, one instance on the host?
Yeah. So the question was, is libvirt running on the host or in a container? And we put libvirt into a container. We softened it. So it's running in a contained environment. So it's obviously, it has more privileges. We turn off some namespaces and but run it in a container. Why do we do that? Because we said we want it to be a native Kubernetes application. And that is, the red line is that you need to make sure that you don't have to touch anything on the host. And that's why we decided to ship it in a container, because now you can run a single command against Kubernetes, and our demo, our work in progress is just working. You don't have to touch your host at all. And it's been tested on Ubuntu. So that's also pretty nice. Is anybody of you working on a similar approach? No? Okay. Then thank you very much. I'm done.